Hi ladies and gentlemen, in this video I tell you about the basics of Python programming, interactive Python, etc. So use of scipy and pylab from the terminal. Let me start with that presentation. So the speech is organized into your learning outcomes, then getting started with Python programming, use of Python 3 pip, and summary of what you learned. What you will learn in this video is that you will learn the syntax of Python, then you will familiarize Python 3 and IPython 3 interpreters. You will learn the data types in Python. You will learn to use text editors for code entry and to run the code. Of course, we will do in editors as well as in command line. Then you will familiarize the pip3 utility for installing other Python modules. Getting started on a Linux machine, what you do is on a command line you type Python 3. So default Python shell appears where codes can be interpreted. So I will show you a demo of that. So if you come here, I open a terminal. Here I type, I will make this bigger so that everyone can see this. So I type Python 3 and a Python shell launches. So here I can type, here I can do coding like I want to import from scipy import math. I want by this thing I import. I told you that is a module called scipy, that's a scientific computing module. Suppose I want to import the math module from scipy, I can do that. If I want to import plot from pylab, I can do like this. Now it's a line by line interpretation. When that input is given, it is received and it comes to the next line or an output line. So here this is a basic Python Python 3 terminal, but it is wise to use an enhanced Python shell. I will come to that. I will exit this by Control Z, and if I come here, I go back to my presentation. Default Python is okay, you can do for many applications, but it is wise to use an enhanced Python shell. So something called IPython 3. So what I can do is I type IPython 3 here, and I type in these codes. These code lines can be interpreted on the command line, and this unlike MATLAB, a function can be written on the command line. So if you are familiar with MATLAB and Scilab, you know that functions cannot be written on the command line, but here with IPython you can write a function on the command line. I will tell you about these things in detail. So if I type IPython 3, when I say IPython, it is we are referring to a Python 2.7 engine, and when we say IPython 3, I am talking about a Python 3.6. Here you know that in the earlier Python 3, you can see that the version I use is a Python 3.6.9. okay, Python 3, okay, and I have a Python 2 also in my system, but that is not being used now. When I say IPython 3, Python 3.6.9 is being is the engine behind that. So I can write say from scipy import star. Import star mean earlier I said from scipy import math. Okay, that introduced imported the math module alone. That here if I say from scipy import star, it imports all modules. This is unnecessary in most cases, but for your experience I tell you this way. So it drops all it imports all modules from scipy. Only the selected module need be imported for the lightness and robustness of your code. You need to install only the required packages. But here I am saying some example from pylab import star. Now all the plotting modules are all the plotting certain scientific image processing modules are now imported into the working domain. Now this is how you write a code in a command line. Now I can write some more lines also, like if I say x equal to say 1 comma 2 comma 3 comma 6 comma 7, it is a list. If I say type x You can see that's a it returns the value. So this is an in this is showing an in one, that says it's an input line. These are all input lines. Now there is an outline here in orange, that is a list. It says that the type of x is a list. Now I can plot this x like 1 2 3 6 7. I can plot by using plot from pylab. So I see now a MATLAB plot has written a line at this memory location. Now if you want to see this plot, you can say show. You can see this plot. You can add more things to this plot. You can see that this is these values are given here. So I can add more things like plot x. I can say grid is on, you can say, so that it puts a grid on the graph. Okay, then you can say show. Now you can see that there are grid lines in this and a plot is created. Now you can save this graph as a PostScript file or whatever. I can save this file as a PostScript or PNG or PostScript. Preferably I use a PostScript. Okay, something called encapsulated PostScript. Okay, I can save this file as some file dot. I can say some test dot test plot dot eps. Okay, so PostScript, you know what PostScript is actually a language. PostScript is a kind of code or language that is used for communicating with the printer. So it is very easy to incorporate PostScript into LaTeX. So we prefer PostScript always. Okay, so I save this file as a PostScript file, and this is how I work with the terminal. This is how I interpret Python codes. Or else I can use an editor. You know, Linux is a text-based operating system. It is full of editors. So I can open an editor and do this. I can save a code somewhere with a file extension .py. I can use any editor like a Nano or VI or Gedit or Medit or whatever editor that is available to you and that is easy for you. You open it and type up the code in that and save that file as a name.py. Okay, then on the command line you can run this file. I will show you that. I will demonstrate that with I will use some text editor like I use a gedit here. Okay, I type here from scipy import star from pylab import star. So x equal to some 1 comma 3 comma 6 comma 9 comma 10. Okay, then plot x. Okay, then grid on. Okay, then what you say, if you want to save it, you can say save fig. Save fig is also a module in pylab. Save fig, you can give some name, some test output. I say test op. I should put them as a string. Okay, these strings are put in quotes. Test op say dot eps. I save it as an encapsulated PostScript format. Then I say show. Okay, now I have to save it in this file in some location. I press Ctrl S. I save it in my home directory. Say I say test1, some name I give, some test1.py. Okay, now I have to go to the location where this thing is stored. Now it is in my home directory. This is in my home directory. So I write run test1.py. Okay, I run test1.py. So now it does the computation. Now if you here you can see that if I close this, you can see that some test op is written in my folder. Here if you go to my home directory, if I search here, this file is saved here. Okay, this file is saved here as a PostScript file. And you know the quality of a PostScript, this is actually a text thing. If you open it with a text editor, you can see that this is just text. If I open with a text editor like open with a text editor. You can see that this is just a text. It's an Adobe PDF PostScript file. This is just a text. So PostScript is nothing but ASCII format. So you can easily integrate that with your with your source files or with the source LaTeX files. So let me go back to my presentation. So this is how you run the code in an editor. You type the code in an editor, save it as a name.py file, and run it with the execution run name.py with the run name.py in an IPython environment. So in a Windows machine, you click on that button, like some icon is there. If you install Anaconda, you have this Python, IPython, etc. There are some built-in editors in that for Anaconda distribution. You can run like this and click on or run using run file name.py. Now the data types are, you don't have to worry much about these data types at the moment because you pick these things as you go along. The programming with Python is very easy. It is much easier than C or C++. It is almost as simple as English text. So one is numbers. Numbers can be integers, floating point, fractions, or complex. It can be Boolean. It can be true or false statement. It can be string. I told you string already, like grid on. Save fig, that thing as those things are given as strings. Then lists are there. Already you saw the list x equal to 1 2 3 5 etc. Tuples are there. Then byte arrays are there, sets are there. These are the basic things in Python, but scipy etc. adds more data types like arrays, integer arrays, those things, floating arrays etc. More data types are added by scipy etc. These are the built-in data types in Python. So when you will be needing many modules in data analysis only, you will be using Panda, scipy, numerical Python, XLRD module. Many modules you will have to install and use. So for that, for installing this Python packages, you don't have to go to bigger installation. Instead, you can use something called a pip utility. So what you have to do is first you have to install a Python 3 pip. Okay. So that is a versatile utility for installing Python packages. So that Python 3 pip can be used with yum or apt, like sudo apt-get install Python 3 pip. So what you get is it gives you a new command, that is a pip3 install. First you install the package called Python pip, Python 3 pip. That you can install with apt or yum or something. Sudo apt-get install Python 3 pip. So when you install Python 3 pip, you get a new command called pip. So that you can use for installing other packages. So you can use the command sudo pip3 install package name. Suppose if you want to install the module XLRD, that is for reading Excel sheets, you can use sudo pip3 install XLRD. That will install XLRD. If you want to install the module OpenPyXL, what you can do is you type sudo pip3 install OpenPyXL and it will be installed. And what you learned in this session, or you learned the syntax of Python, you run some simple codes, you familiarize a Python 3 and IPython 3 interpreters, you know how the execution is done. Then you understood the data types in Python, you learned to use text editors for code entry and to run the code. Then in the end you saw about the pip3 utility for installing additional Python packages. And that is the end of this video. I thank you all.